Hey everyone, it's Sam. Today, we're diving into the fascinating world of adhesives, the unsung heroes holding our world together. We'll tackle the top challenges faced by adhesive formulators, from balancing strength and flexibility to navigating environmental regulations. So buckle up because things are about to get sticky. Let's talk about the eternal struggle in adhesive design, finding that sweet spot between adhesion strength and flexibility. If your adhesive is too rigid, it might snap under pressure. Too flexible, and it might lack the strength to hold things together. One trick is using block copolymers like SBS, which have segments that are rigid for strength and segments that are flexible. By tweaking the ratio of these segments, we can fine-tune the adhesive's properties. It's all about finding that perfect balance. Time is money, especially in manufacturing. Controlling the cure rate and open time of an adhesive is crucial. Dual curing systems, using UV curable components and heat-activated initiators, provide an initial rapid set and then complete the polymerization process. The UV light gives us that initial rapid set while the heat ensures a strong and durable bond. It's like having two superheroes working together. Adhesives need to stick to all sorts of surfaces, from smooth metal to rough wood to slick plastics. Each material has its own surface energy that affects how well an adhesive will bond. We use tackifiers or adhesion promoters to help different materials get along. Chlorinated polyolefins act like tiny anchors, enhancing the adhesive's grip on stubborn surfaces. We can also treat surfaces with techniques like plasma or corona discharge to make them more receptive to bonding. It's like giving them a spa day. Let's talk about viscosity and rheology, how the adhesive flows and behaves during application. You need the right consistency for the job. If it's too thick, it's like spreading peanut butter on a giant piece of toast, messy and inefficient. Too thin, and it'll run all over the place. Thixotropic agents allow the adhesive to be thick and viscous at rest, but thin out under sheer stress. They prevent it from dripping or sagging, making it easy to apply and spread evenly. Think of it like ketchup. Give it a good shake and it flows right out of the bottle. It's all about controlling flow. Adhesives often have to withstand intense conditions, like scorching heat, freezing cold, or exposure to harsh chemicals. Fluorinated polymers and silicone-based adhesives are like the superheroes of chemical resistance. For thermal stability, we use reinforcements like graphene and carbon nanotubes. These tiny particles act like miniature heat shields, preventing the adhesive from breaking down at extreme temperatures. It's all about making our adhesives tough as nails. We can't talk about adhesive formulation without addressing environmental impact. Traditional solvent-based adhesives can release harmful VOCs into the air, so we're shifting towards more eco-friendly options like water-based systems. Emulsion polymerization is one technique we use to create these environmentally friendly adhesives. We're also incorporating bio-based monomers, derived from renewable resources like plants. It's like trading in your gas-guzzling car for an electric vehicle. Have you ever opened a bottle of glue only to find it's dried up or separated into a gooey mess? That's why we put a lot of effort into maximizing the shelf life and storage stability of our adhesives. One cool trick is microencapsulation, putting the curing agents in tiny protective bubbles. We also use inhibitors and stabilizers to extend shelf life. Think of them as preservatives for our adhesives. We want to make sure they're ready to go whenever you need them. Cost is always a factor, but we don't believe in sacrificing performance just to save a few bucks. It's all about finding that balance where we can create high-quality adhesives at a reasonable price. One way is by exploring cost-effective alternatives to expensive raw materials. For example, using calcium carbonate instead of high-priced fillers. It's like finding a hidden gem at a thrift store. Not all adhesives are hidden from view. Sometimes they need to look good too. For applications where the adhesive needs to be invisible, we use optically clear adhesives, or OCAs. These are formulated with special resins that resist yellowing over time. By carefully selecting our photo initiators, we can prevent discoloration caused by UV exposure. It's like applying sunscreen to our adhesives. We need to make sure our adhesives are a perfect match for the way they'll be applied. Whether it's spraying, dipping, or screen printing, each method requires specific properties. For vertical applications, we add anti-sagging agents to prevent the adhesive from flowing downwards. It's all about customizing the adhesive to fit the application like a glove. And there you have it. We've journeyed through the exciting and sometimes sticky world of adhesive formulation. If you enjoyed this deep dive into the world of adhesives, give this video a thumbs up, share it, and subscribe OnlyTRAININGS for more knowledge boosters. Until next time, stay curious, stay creative, and keep those ideas sticking.